My intention was to come up and do quite a bit of work in here over Christmas. I had a couple of weeks off and a few days free, so I was going to come and really progress things. But as usual, things went a bit wrong. I'd really started getting these infrared sensors in because they're really seeming to work. So I was drilling the holes, getting them stuck in there, getting them working, and getting the wiring done for them under here, which is now a bit of well, it was always a bit of a minefield, but now it's even more of one. I ended up with another fried Arduino, and I haven't got it fixed yet. The one that's up here, I think, is the fried one. And I think really it's obviously it's because of all this wiring, but also these boards that go on top of the Arduino, the I/O boards, they're really no, if it's actually really difficult to use if you're going one pin at a time. It's they're small boards, and it's really quite difficult to get the pins into the right holes and be confident that you've got the pins in the right holes when there's a load of pins surrounding them. These are test boards. It comes with the territory, and I think well, I was really struggling to get the pins in. So what I started to do was pull this board off the Arduino, and then I could maneuver it around a bit more, and then I could get the pins in. Then I put the board back on the Arduino, and that was laziness really, because the Arduino was screwed to this backboard, and I couldn't really get at the screws if this board was on. So that's what I'd done, and then I pulled the board off, and I got the IR sensors plugged in, and then I put the board back on the Arduino, turned everything on, and everything fried. So I'm assuming that when I put the board back on here, I'd missed some pins, got some short circuit, and killed it. So it really is quite unsustainable. So I'm unsustainable in the sense that as I add these sensors one by one, the infrared sensors, it's going to be really difficult to plug them into this board. And there isn't really an alternative to using that board. So I need to look into solutions that will make these boards easier to use and make it less problematic when I add new pins onto them. The current temperature check, so BBC is saying it's 7 degrees outside at the minute. I think the sun was out, I don't know if it still is. And in here it's telling me we're 10 degrees. Obviously there's no heat source in the loft, and there's great big thick insulation as well separating the loft from the rest of the house, so it really is kind of a little bubble without any real source of heat. Excuse the always there mess. I've decided to go right back to the beginning, fix some of the things that have been niggly for a while, and quite minor things, but I decided I was going to fix them. So I'm back on the test rig thing, and I've just got a simple down in the computer down there's a USB to RS485 adapter, the pink and purple cables coming out of it into one of these TTL things, and then TTL going into an Arduino, and that's it. So I've just got the basic kind of test, make the light come on and off thing. I've gone back to basics though, because I've always had a problem, and I've mentioned it in other videos, with the serial bus that connects to RS485 from the Arduino being the same serial bus as the one that connects into the computer, which makes debugging difficult, and it makes uploading sketches. What tends to happen when these things break, and I think I've got another one broken upstairs, which is what's got me to this point, when these things break, they flood the serial bus. So that makes it impossible. So there's all kinds of data flying around on the serial bus, and it makes it impossible to debug anything or upload any new sketches to try and debug something, because this is on the same serial bus. So you can't upload anything because there's just loads of chatter and mess going around. Now, an Arduino Mega has multiple serial buses. So I decided I was going to try to get the RS485 communication working on a completely separate serial bus to the USB serial bus, so that effectively the two things could happen at the same time and not affect each other. So the start point for this, the thing that had really got me interested and made me think it was possible, is here in the GitHub code for the Auto 485 library.
And the Auto 485 library, if I just grab a bit of Arduino code and bring it over, this is for one of the nodes. This is one of the live nodes. It doesn't really matter which one. Right up at the top, somewhere here, we have an Auto 485 definition. We have effectively called the Auto 485 library, which is downloaded and connected, available effectively to this sketch, and it just calls it with the DE pin, the communication pin, which is pin 2. But I had, for a few reasons, been looking at the source code for this R848 Auto 485, and what I'd seen, I don't know if it's here in the examples, maybe not, but I'd certainly seen it in the source code. Is it? This is the constructor effectively. This is how you call it and how you initialize it. So here you can see int DE pin. So that's saying integer of DE pin. So you can call it with just that value of 2 and off it will go. But you can also call it with a few other piece of information. The RE pin, and that's if you've got if you don't have the two cables connected on the two TTL, the two middle ones, you can have separate pins for receiving and transmitting. But also you've got a serial port here. So I started to think it might be possible to, if when I instantiated this Auto 485 class, if I define which serial port I'm using, then maybe I can keep the two serial ports separate. So I started, because it's always easier to start with the basic stuff and not the really complicated stuff. So I started with the simple RS485 blink sketch. And here I've now, it seemed that you needed to, I don't quite know how C++ class instantiators work. It seems slightly different to C#, which is what I'm used to. So I just went for the full, all three values, using the same value for the RX and the DX pin there, so that it's sending 2 for both of those pins, and it's sending serial 1, not serial, as a serial port. So back into here, I'm sending 2 for that value, 2 for that value, and serial 1 for that value. And here you can see it handles, if DE and RE are both the same, it does handle that. So I'm quite happy that that's going to work. And here you can see it's assigning the serial port value to serial here. So if I send that value in, please communicate with serial 1. That should work okay. So having done that, I then set up, I've got Panel Pro just running on this PC, not really doing anything, but I have got a serial connection for the USB to RS485 adapter that's plugged into COM6 here, and it's got a node configured, which is appeared on the screen as well. It's got a node configured, which is obviously the TTL, equates to the TTL module that's plugged into the Arduino. So then, no, I didn't change them. If I go and grab the serial monitor, I've got a little bit of debug output on the serial monitor, which should still be around, which is here. And it's just outputting the value of that simple LED. All the LED sketch does, the RS485 blink switch, is you can map one light in Panel Pro to the LED on the on board the Arduino, and you can turn it off and on. And one more window here. So I've got simply got the output of that CMRI output in here on the Arduino serial monitor, and clicking on and off here, I can see that it's working, because when the light's off, I've got a 0 there, and when the light's on, I've got a 1 there. So that means that the connection through the RS485 is working. One more thing, and I'll put links to all of these in the description. I had to look up the serial ports for the Mega, because obviously using 0 and 1, this is where I fell down, because I think I've tried this before. If I use pins 0 and 1, I think most of the guides tend to have you connecting your TTL module to pins 0, 1 and 2, and 0, 1 are the serial pins. The problem is pins 0 and 1 are the pins assigned to the serial interface on the Arduino, not serial 1. So this page gives you the information you need. It says actually, if you want to use pin serial 1, you have to use pins 19 and 18 for serial communication, and that was the thing that unlocked it all. So rather than having pins 0, 1 and 2 connected to the TTL module, you need pins 19, 18 and 2 connected to the TTL module.
So now I've got a basic working system. I'll probably take most of this upstairs and plug it into that corner that's not working at the minute, because I know that this simple setup works. But I really now need to think about what I'm going to do to make these pins more accessible. Once this Arduino, like I said before, once this Arduino is pinned onto a board and a few more cables are plugged into it, it's very difficult to get new pins for new sensors, new lights, LEDs, whatever I add to the layout. It's very difficult to get them plugged into the right pins and to know that they're in the right pins as well, because you can hardly see anything. So what I'm going to do, and I've got a bunch of extension cables like this, which are pretty cheap really, they didn't cost that much. Starting in the middle, because it's always most difficult to get pins into the middle when there are other cables around. I'm just going to plug loads of these 3-pin cables and go along both directions, and therefore extend where the actual connection for sensors and LEDs, whatever, is made from. Instead of it being actually on the board and being picky and difficult to get at, it's actually going to be into these 3 here. Obviously I'll have to put stickers on each wire to say what pin number it is and what order these cables are in, and the ground voltage and signal. Once that's done, it should be much easier if I'm adding a sensor, adding something to the Arduino, and this is all in place in situ upstairs in the loft, all screwed to a board. Instead of having to pick my way in and plug stuff into here, I'll just shove a couple of cables into there instead. Still in a bit of a state of flux down here, but I have got the TTL module that I was testing wired in here somewhere, and the sketch updated to use serial 1, and the connections on here going into the serial 1 pins rather than the serial pins. So I'm now going to try and start everything up. I don't have the infrared sensors plugged into this replacement Arduino yet, but I do have the micro switch sensors and the connection to the servo driver board, so there should be some kind of life when everything turns on. So the 3 separate corners the boards the Arduinos are on, I'm now going to stretch in and open Panel Pro. I'm hoping there won't be any sound, any movement from the motors, but I should get sensor information. So when the diagram of all the points comes up, it should have accurate readings. Basically I'm looking for black circles and red circles, which will indicate that it's all working. Right, so some kind of progress. The top 4 looking good. This left corner is looking good, but there's still a problem with the problem corner. And I think, yeah, they are flashing black and then they're flashing red again, which to me suggests, I've seen this before but I can't remember what the solution is, but to me that suggests that there are responses coming back from that corner. So all the cabling is probably incorrectly, but some of the requests that are coming from this machine, from the Pi through that RS485 module there, some of the requests for sensor information that go out to the Arduino are not being received back, and that's when it goes red. So there's a performance or a connection issue down in that corner. So either the Arduino's struggling and it's not getting information back as quickly as it can, or there is an RS485 connection issue. And I think really it's going to be one of 2 things. Either I've got too much console logging, too much output to serial 0 going on in the sketch, and that's slowing the Arduino down, and I don't think it's going to be that. The other thing is that the TTL module that's over in that corner is in the middle of the RS485 bus, so it should have right in the to the left of that little 8-legged spider, the chip there are three kind of 6 little pads, 2 sets of 3, and they've had they're where the terminating jumpers are, whatever they're called. I can't remember what they're called now. And on this one they've been removed, and it's kind of visible that there are just 6 solder pads there with nothing attached, whereas to the right you see that row, that column of 4, the little jumpers are still on there, whereas over here they're definitely removed. I'm wondering if, because it's in the middle, and in the middle the terminators, obviously you only want terminators at each end of the RS485 bus, not in the middle. So I'm going to try, and I think this is a knackered one, but I'm going to try and remove the jumpers from the TTL module that's working, and see if that makes a difference. I suspect this is going to be very difficult to film, but I'll have a go. So what I'm going to try and do is desolder these 3 jumpers here. I think I've got a heated up soldering iron. It really isn't very easy. I guess it's just a case of applying enough heat so that the solder on the pads underneath releases, but it's not. I've never found it to be the easiest of jobs. Oh, there's one off, I think. I don't have great eyesight either, which doesn't help. You don't want to apply too much pressure, because when they come off, you don't want to be flying into your hand with a soldering iron. So I don't care what state they're in when they come off, I'll never get them back on again. And these things only cost £1 each anyway. Oh, there we go. That's a bit too much pressure. That was, amazingly, when I was filming it, that's the easiest one I've ever done. So that's the 3. Has it gone slightly out of focus? That's the 3 terminating jumpers off there. So I'll now get it plugged back in upstairs, and I'll remember to turn my soldering iron off and see if I'm getting better communication on the RS485 bus. I've now connected up my newly soldered or unsoldered, desoldered TTL module to my little test Arduino. It's connected to the test version of the test CMRI bus and Panel Pro, and I'm now going to just try turning the light on and off on the Arduino from Panel Pro GMRI. Finally remembered its name. And the LED, onboard LED on the Arduino is going off and on, which means my board is working. So I'll now take it up back into the loft, plug it into the problem corner, and see if I get a better performance in response to requests from CMRI up there. So the moment of truth. See if this has made any difference to the responsiveness of that bottom right corner. Well, oh, that might just be a yes. So it looks like for that node that was in the middle, it was absolutely the terminating jumpers. So actually, I don't know if the video caught it, but just after I praised myself and declared success, all of those bottom right corner lights went red again. And I've just suddenly had a thought, an idea that I completely forgot about, actually. This is the old board down here, and I'm just keeping it. This is the one that was attached to the Arduino that's now fried. And I'd completely forgotten about the common ground, and that's the white cable that's going into the blue box at the front. And I haven't connected it to the new one. It's still connected to the old one. And I remember that was what was causing me all kinds of communication errors and timeouts before, and I've checked on the metrics, it is timeouts. So maybe, just maybe, it's actually, very probably in fact, that this new Arduino is not yet connected to the common ground cable that goes between the RS485 USB adapter all the way over at the Raspberry Pi and all the way along the layout and connects everything up to a common ground. So I'll connect that one up now. So let's try again. The Raspberry Pi is just starting up. I've connected the common ground into that Arduino now. Will this make any difference? I'm kind of quietly confident with this one. This is where I had the issues last time. It'd be very interesting to see anyway. And that's still a big fat no. So despite my unwarranted confidence, I found myself, even though I thought I was going to work, in a much worse state than I realised, because yet another Arduino had fried. In trying to fix the Arduino, or get some life out of it, so once it's fried, Windows could detect it, or would occasionally detect it, but wouldn't know what it was, and it didn't run any sketches, and you couldn't upload any to it. So I had the laptop down here, and what I realised, so I connected the USB from the laptop into the Arduino, and the laptop immediately shorted and switched off, as did the Arduino. There's a message from my daughter on the screen. And then what I found was, it appears that the USB bus system, whatever you want to call it, on the original laptop, which is underneath that one, was completely fried as well. I couldn't connect anything to the USB, to any USB socket on that underneath laptop, and get any life out of it. So I brought another laptop up, which is this one, which has got a broken keyboard, which is why it's got another keyboard on the top of it there. And I've connected everything up, and it's working okay, because I thought if it was shorting out that catastrophically and taking USB buses and Arduinos with it, then there must be a terrible short, bad connection, bad cabling, whatever up here. But actually what I think it is when I was screwing down the screw on that nearmost blue block there to put the ground cable in, even though I've got all kinds of tape, insulating tape on top of this metal USB socket here, the pressure of trying to screw that cable in has pushed the board through the insulation, and it's made contact with the USB thing. Now I don't know what, I'll come down here, I don't know what on the bottom of here, I think it's around those four, it's that stuff there on the underneath. Is it this side? So it can only really be those two by the little tick mark, those two little connectors there, and they are connected to a jumper on the top, and I must admit I don't know what the jumper does, but it seems like if the board is shorting out on that jumper while touching that USB, the metal casing of the USB connector, and a laptop is connected at the same time, possibly on the same ground circuit, I'm not sure about that, then you get some massive short, and it takes out all kinds of stuff. So obviously I'm quite annoyed that I've lost possibly a laptop and yet another Arduino, but I am a little bit relieved that there isn't a cabling problem in here, and that I appear to know what the problem is, because now with all the same cabling, just putting the same shield on top of yet another new Arduino, I'm having no issues. I'm having no shorts. I can connect USB up quite easily with all the same connections, and it's doing what it should. So I've insulated and extra insulated down here, underneath as well. So there's a strip of tape, if I get this one again, kind of right across there, and then about 4 or 5 layers of tape on top of the socket there to try and stop whatever these shorts are. And obviously I need to be a little bit conscious. You can see there's a little bit of a gap there as I kind of try to manually keep the thing lifted up as well, so that there is a gap. But obviously I can't prove it, it's just a theory, but that does seem to be what it is. I am happy now that I think I've got to the bottom of this problem with frying Arduinos. I do think it was those 2 connectors on the underside of the sensor shield making contact with the metal casing of the USB socket. I think it's maybe exacerbated in my case in that the laptop up here that it was connecting to, the very bottom one of that little pile of laptops now, has had battery problems for years and can't charge its battery. So maybe there was some kind of earthing issue with that as well. I'm not sure. But it was an old laptop and I've replaced it with another old laptop, so it's not really a big thing. But I do think it is that contact thing. And also actually in editing all the stuff from yesterday I was doing down in the office together, I did notice that whenever I was putting pressure on the sensor shield on the Arduino that was down there, there was an audible USB disconnection sound coming from the computer. So, and that was the same thing. It was just, if I was putting any pressure on the top of that shield, the Arduino was shorting and it was disconnecting. It was the computer was losing it, which is the usual behavior. I've only had the mega shorts and issues when it's been connected to that laptop down there, so I think that might have been specific to me, but I'm glad that it's that it appears to be resolved now. I'm still having the performance issues. I'm still getting those the sensor, the red and black circles flashing all red. So I still have performance issues down there on that Arduino, but I think I know what it is. It's nothing to do with the RS485 now. It's to do with when I've switched and moved all of the connectors for the micro switches that are all underneath there connected to the motors. I think I've probably wired up a few of them incorrectly, and they're still messy anyway. So when it's trying to read all of those sensor values to send back to JMRI, CMRI, it's at certain points its performance is being affected because cables are not connected where they're supposed to be and that kind of thing. So that's where I'm going to start investigating now, but I think that's for another video because this one's already really quite long. I think these videos like this, I've edited together, and I know it's boring. It's not exactly the most scintillating entertainment, but it's what I'm doing, and I don't know, there's not much of it around on the internet, so it might be useful to put up just in case someone goes down the same route as me, and maybe they'll get a few tips on how to troubleshoot issues. So I will, now it's all edited together, I think I'll post it up there today. Once I've got that corner working, which I don't think will be very long, I'm going to nicely label up all the cables as well and do it a bit more neatly. Back onto the infrared sensors. There'll kind of be infrared sensors sort of around there, and then in the middle somewhere, and then down here as well. And I do kind of feel like I've got kind of a new impetus. I've got a bit more enthusiasm for it again after really quite a long break. So I am planning like new year, new start. I'm going to get on with it. It's got gradually very messy up here, which is unsurprising knowing me. So another job right at the top of the list is to really have a big clear out and tidy, because it's actually quite a pleasant space, a pleasant environment to be in up here. So I think it would be a lot more pleasant if it wasn't just full of strewn cardboard boxes and stuff. So I'm going to have a good clear out and a sort out, try and make it a little bit less cluttered than it is now. But for now, that's it. I'm going to get on with labelling up cables and sorting out that corner, but I'll get this edited and posted up today.